Okay, so for our second video on linear regression, I want to just go back really quick to a simple linear regression and show you its similarity with the Pearson correlation as well. So in our last video, we did a linear regression on life expectancy. And we can go ahead and do one of those really quick. Again, I'll just call this one Model 2. And we'll do life expectancy 2017 and percent smoking. So we're really just doing now, in this case, this is a simple linear regression model, not a multivariable one. It's just a, one variable. Some people might call it a bivariate model. And we've ran it. Now I'm going to do summary on Model 2. And here's our adjusted R squared. 49% of the variability in life expectancy is explained by that single smoking variable. And you see the multiple R squared is 0.4923. If you were to do a Pearson correlation, so core, and we'll just, we can do either of them. We can do core test. And then we'll just do, was it life expect 2017, comma, smoking, or what was it, smokers, capital one, that one. We get this correlation number of 0.701657. Now, I'm going to take that number right there, copy it, right? Now I'm going to put it over here and multiply it by itself. So that is actually the correlation coefficient is R, and now we're going to do R squared. We're going to multiply by itself, and what do we get? We get 0.4923. All right, 0.4923. 0.4923, and voila. 0.4923. So Pearson correlation, R, is very much that in a single, kind of bivariate analysis, X versus Y or Y versus X or whatever you want to call it. That gave us this nice, strong negative correlation. So that correlation coefficient, negative 0.701, it may sound high, and it's still a pretty strong correlation there. Again, this is ecologic data, so we don't want to fall for the ecologic fallacy, but it's still a pretty strong thing. The counties that smoke the most have the lowest life expectancies. But when you square it, it doesn't look as big of a number. And when you square it, it also gets rid of that negative sign. So the squared, so at R squared of 0.4923, it may sound really low to somebody compared to the 0.7016, but it's the same thing. So that's R, and that's the R square. Now, there isn't a multivariable Pearson correlation. The closest thing you got to a multivariable Pearson correlation would be doing linear regression. So it's important to just kind of understand that relationship. So I'm going to stop it here and just letting you know that relationship.